Hey folks on Zoom. Um, we should likely extend the deadline to Friday or Monday.
With that.
Um, I'm fine with either, but just when's the due now? Let's just move it to next Monday, I guess. Yeah, cool. November 3rd. And there will be two more homework, so hopefully get it done as early as possible. Homework 6 is also already up, even though this is likely one of the most like the trickiest homework you will ever encounter in this class. Polyphonic. We will look into it, and it's one of the most trickiest thing in max. So leave some time for that. Otherwise, we would just extend it homework 5 to November 3rd. I will send an email to see if our Pet Suite staff can update the list as soon as possible. Otherwise, once you've done the Canvas training, you don't need to do the in-person one. You should be able to get access to this room. Or you can just sneak in for other classes. Cool. I mean, the files can be found here, like this folder link. You can find the max patch we are using in class. Yeah, cool. So for homework 6, for homework 5, likely what you want is from this MIDI keyboard thing. Anyway, you can download it and just copy paste the select part so that you don't need to key in these things. But anyway, it's not that trivial. You have to basically combine the key and key up thing with the, the selection part. But basically you're, blending concepts together to do it. Cool. Let me grab the
Next to this one's.
well, let's look at what we talk about. Let's stay. Any questions on Max? Lots of yeah, I mean that's totally usual, especially when you are entering from a more traditional programming background. You will figure out that Max just doesn't work the way as you might expect. But at the same time, later after you complete several homework, then you will get to like it. There is some reason why it's designed in this way, and there's a reason why people are using it, because it's just a fundamentally different paradigm or like a mindset of how you work with programs for live performance. So yeah, last week we talked about how we can start from building a MIDI keyboard rather than just directly synthesizing sounds. But in Max, it's not too tricky. So note out, that's likely what you will be working on in homework 5 a lot. Program out, that will set the program, anything but drums. So drums will be controlled by channels, which will be the third one here, the channels. The first one would be pitch, velocity, and channel. So in this case, you wanna, I don't think I turned it on yet. But anyway, you want to trigger, it's not starting. Weird. Did I turn it off? Oh, I turned it off. There's no sound. Cool. So this is like you turn on the notes and then you turn it off. So that's essentially what homework file you are trying to do. So you just not only turn it on when you key up, you want to turn it off. That's essentially what's doing. So, we talk about it, but at the same time, we just realized that, well, at some point, if you want to just click it and you don't really care when you are, lifting your key, then, it makes sense to use this make note where you have the duration set up. But this is not the case in homework 5, where in homework 5, the duration is determined by when you lift the key. So the idea will be when you press the key, once you detect a key event, then you trigger the node on event, which is velocity of any value but 0. Now, once you lift it, key up, then you trigger a node off event by sending 0 velocity with that exact pitch to that. So, we talk about this, key display thing that you can play with, but you can also just show it by, having it. And we also talk about this select thing, but basically select 0, 1, 2, 3, 4. It's not, because we are doing 0, 1, 2, 3, 4 here, but it's actually doing matching. So this piano things will actually send, whether it's like this 0, the first, the second, the third, or the fourth option that you have. And select will route based on the matching to these outlets. So these outlets correspond to 0, 1, 2, 3, 4, and nothing. If there's no match, then it will just send the inputs directly route to the outputs. So you will also play with this, but things will be a little bit tricky. So in this case, when it is drums, which will be 3, then it will be this outlet, match 3, then it will send to trigger this channel. But now the problem will be, in workflow is that once you click back to piano, how can you reset that back to 0? So do some routing, have fun with Max. Any question on this? Cool. Feel free to copy paste some of these. Likely you will need this part plus this, but you will need to fix the drum part. Cool. Yeah. And this is essentially how we can actually use our keyboard, like our laptop keyboard to do it. So, you will have this key event that basically track what you are pressing. So, A, S, D, F, G, H, J, K. So you will see that all the different notes here. And these nodes will be routed to a specific node. That's basically how you map it. So, again, feel free to copy paste this. This is basically what you need. So you route 97 to 60. So 97 will be A, so A will be C, and 119 will be W, W will be C sharp, 115 will be S, will be D, so all the way until high C. So this is like a very simple, way to work on keyboard. And now, this make note things doesn't really make sense anymore if you want to do it in homework 5. So you likely won't need these. But the idea is that whenever you have these key on, then you want to set like a note on message to note out. But at the same time, if you have key up, then you want to set it differently so that you turn it off. That's the idea. And to turn it off, a nodal event will be velocity 0. That's the point. So, cool. Other than that, these are just other options how we can do it in a different way. You can do it with this funnel thing to avoid this, chaotic chords, but it's also fine. Just leave it that way. It's actually more straightforward. We could also use a JSON file to do it. Cool. And last week, we basically talk about a bunch of things. I won't go over it again, but, we talk about this metro thing, metronome. You could create rhythm. But more importantly, it's like this hot inlet and cold inlet thing. You will also see that in the message thing. So the message, you can use the black one here. So all the cold inlet will be blue and the hot inlet will be red. Very intuitive. So, even with your message, you likely notice that there are like two outlet at the top and one inlet at the bottom. So the left inlet is actually a hot inlet. And if you hover onto it, you will see that it's actually like you can send a bang message to trigger it. Bang message to trigger it. So you can add a button, you can add a toggle, add whatever things that will trigger these things. But this will trigger whatever inside it. In this case, say, I don't know, XX, then it will send an XX out to its outlet. But the right-hand side is a code inlet. So if usually we use this to print something. So in this case, say you have like I don't know, like a hello entering, and then you press this thing, and then it will trigger this thing to turn it into hello, but it won't send anything out. Once you trigger something here or you click the button, then it will send this hello out. So that's the difference between hot inlet and cold inlet. Cold inlet will sort of like turn the inside state of these, will change that. Say in this case, change the internal XX into hello, but it won't trigger output. Only hot outlet, when there's a bang to the hot outlet, it will trigger the output. So that's the difference between hot inlet and cold inlet. So in this case, I click the things, it won't. It will override this +3 because plus -1, so -1, but it won't trigger the output. Cool. You can actually turn it into a cold inlet into a hot inlet by using trigger bang guy. You can also use TBI, but basically this will turn this message into a bang and an integer. So integer will be the inputs. So these things will be routed to I, and bang will just send it to here. So now you have a bang to trigger the hot inlet, then it will trigger a calculation. So that's a little bit tricky, but you can see it all the way in different max patch. You can also use this expression thing. So this is essentially how you can turn like a MIDI note to like a specific frequency. So you can use expression. So the tricky part is that you just use the $ I1. So that will be the first integer. $I is integer, 1 is the first integer. So in this case, this expression, once you enter in, it will look at how many these you can have like $I1 plus $F2 times $I3. So this will create, sort of like 3 inlets on top. So it will dynamically change the inlets numbers, and you have to number those inlets correctly with the correct data type. But in this case, it's just 1 inlet, 1 outlet. So you can think about you are actually potentially just writing a function in this case. Cool. So we can actually have this like simple sinusoid synthesizer. Basically, grab a MIDI number, turn it into the actual frequency, and then we send it to cycle tilde to get the output. This is so commonly used, so we have M to F and F to M to do it. And we talk about this message ordering, which is very counterintuitive, but right to left, bottom to top, that's how Max execute anything when they are aligned. So if there's any tiny, sometimes even not mutually distinguishable, so it's always nice to align them. But most of the case, you won't really care about the nuance ordering of your max patch, but sometimes you want to create a special effect, then you might need it. Cool. Mouse keyboard control, basically things in processing, we can of course do it in Max. Max is more high level programming language, so a lot more stuff that you can use without, coding a lot. Key and key up, that's, likely you are familiar with in homework 5, and you will get more familiar with it after homework 5. Other than that, we also talk about mouse filter, where it's easy to help you to sort of like avoid those, abrupt change while you are moving around. Cool. So at the end, we stop at somewhere at this simple synth thing. Cool. So we can actually, hopefully it's not too loud.
You have to connect your node out to a DAC for your sound out? Or can you
No out?
Node out.
You mean MIDI?
Yeah, like
A MIDI, you don't need to do it.
my key's being recognized. I simply make note, but I don't know, it was working last class, but right now I don't get any output.
Yeah, like we do. Yeah, like we do. You have the PWM up, like this default to 0. Likely the audio routing.
Well, I went to the preferences and I changed it to Mac mini speaker output.
Yeah, but the MIDI thing, last time we were talking about it. I forgot how you did it. So, like, do you remember or the inside?
Oh,
Yeah, likely that's it.
no.
Cool.
Yeah. Yeah, acceptable.
Cool. Let's look at this. So yeah, last time we were basically talking about this, and we will soon getting into more of these. I hope there's no sounds actually. Cool. So this is like just a sine wave. Should be kind of self-explained, kind of. Basically, you have a 440 cycle, and you times it with 1. Of course, it will be the same. But now you can actually turn this lower, and you can change the magnitude of that. And that's essentially just AM, amplitude modulation. We will see later. Basically, you can modulate the amplitude based on a specific waveform. You can also use sinusoid to make this sound effects. In this case. But we can also make it modulating the frequency directly. So now we are not modulating the amplitude, now we are modulating the frequency. This is going from 0 frequency to 440 frequency, and just keep doing it again and again. You can also make it so these sound like weird, but you will see later that it can actually be transformed into FM synths, and FM synths is sort of like I forgot the exact era, but it has been there for a while, quite a while, where you can actually create a lot of like early time computer music. Cool. So let's jump into today's part. Any questions? Any other things? One thing, some of the helpful thing is that when you connect these two things, if you want to change it, you can actually click on it, and there's will be this like green button at the top and the red button at the bottom. So you can actually grab it, say now you want to turn this into the other one. You don't necessarily need to delete it and reroute it. You can reroute it by just grabbing this red one and move it to another position. And I just learned that yesterday that you can actually do it with multiple things. So you can do Alt and select all of them and then press Shift to move all the things all at once. So there are some, shortcut, tons of shortcuts. So oftentimes whenever you think something is not that efficient, Google and you will find the shortcuts for it, usually. Cool. So today we will talk about additive and AM synthesis. We will start from ADSR. Cool. ADSR. So ADSR will actually use a very cool function. That's called function actually. So the thing. So if I click it, and then you can go to inspector to see what's its name. So this thing is essentially function. So at the top, you see that function. So you can actually create new function and then click enter, then you will get these things. So one thing tricky about this thing is that it doesn't really know what the size of it is that. So in this case, we want to make it the size as 1000. So we want to use set domain $1. So this will send a message set domain 1000 to the things. So let's just get started and try to make some sounds. Cool. So this is like, think about what's going on here, where I have a bank message. I will send the bank message to create a 440 sine wave. And now this sine wave is modulated by this amplitude. So this amplitude will create this line thing. So this line thing will basically turn those numbers that you have at the top. So these things will create these things. 1, 5, 0.36, 52.78, 0.34. So what these numbers are representing is basically, well, I will start from 0. I will go to 1 at E equal 0.36. No, that's not what I meant. At T equal 5. And then I will go to 0.36 at E equal 42.79. And then the next one will be 0.34, this one. So I will be at 0.34 at T equal, what's that? 746. And then I will drop to 0 at T equal 195. So this is essentially what these numbers are encoding. So once you have this function things, when you sort of like send a band message to it, it will send out these things. So you can see that, you can actually change that. So now if we have, ADSR, we have a, smoother attack. Then in this case, now if I click it, you see that the amplitude will rise slowly. If we have a sharp attack, then immediately jump to the, maximum volume of that and then stay at that. So you can actually just change that behavior. So this is what we call ADSR. So attack, delay, sustain, and release. So this model is called ADSR. So, commonly used as the envelope for modulating the amplitude of the audio signal. So the attack is the time. So it's this time. Attack is not, where you go to the top. So because always you go to 1 or maximum value all the time. So you will go to the maximum value. So the time is A. So basically A, E, S, R. So A is actually this time. So this will be A. And then delay will be decay, will be the time taken from the level to reduce to the sustain level. So this will be delay. So these are both time. So now the confusing one is the sustain. Sustain is the level. So this thing is S. And then finally, this thing is R. No, this thing is R. The time taken for the level to decay to 0. So usually these are triggered by the node-on event, and this thing is triggered by the node-off event. So the idea is that when you press it, the key, it will trigger this attack and then soon decay and then stay at the sustain level all the way until when you release your key. Then it will just decay slowly. Release, I mean. So ADSR is a way to sort of like model this. So you can actually use a function object to mimic that. And then you can actually draw something to change that. So in this case, now this is basically doing that. So, you can change the shape of that. Cool. So all of these will, and one thing you notice is that it will send out through the second one rather than the first one. The first one is another things, but the second one will send out all these points. And these points, and you can send it to this line function. So this line function actually take different format. In last class, we just send a 1 to this line. Then this line will just stay at 1 all the time. But in this case, if you send something like 128.6, meaning that I will go to 1 at t equal 28. Actually, these are how long you stay rather than specific time. It's like after 60, stay at 0.15 for 664 millisecond, and then you stay at 0.16 for additional 215 millisecond. So it's not the exact timestamp, it's rather the amount of time you stay there. Cool. But basically you can see that it's like, well, it will rise and then slowly hold at the sustain and then drop. Cool. So that's ADSR. We can do this. I don't know what's going on in this thing. Oh, I think that's the point. It's like, well, now it's your time. Let's try this. I mean, try to get familiar with these because later we will have drum machine and polyphonic FM. Then we will need to do this. So now this is your turn. That we have these, and how do you connect it to become a working ADSR modulator? Cool. Let's try it. So,
Yeah. That doesn't have to, I don't even.
cool. I guess the first thing you should try is to, at least when you click something, you should get something out. So one thing you will need is well, MTF. So you will want MTF. So the things will turn look like this. So this would do MIDI no number in, and then you can turn that into the frequency. And then you will have like the cycle tail that thing to generate the sound. And then the tricky part would be how you can combine the cycle output with this output so that you can get the line and then drag it. Cool, try it. And I mean, at some point you have to try it in next homework. So good to get started with as early as possible. There's no way you can avoid these chaotic things. Things will just get more complex over time. Yeah. Cool.
I have one question about
Mhm.
the drop down menu. Once you set your messages, how do you actually like use it? Like when I lock, how do I?
Oh, you have to unlock it and then. No, you don't set it that way.
Oh.
So you click the I to set it here.
Oh, okay.
And
I see.
you can also set it there, but you have to use specific message. I don't exactly know.
Okay, so you just write it in enter for the next thing, or is it commas?
Really know. I think enter. I usually just try enter, and if it doesn't work, then or maybe go for it.
And I know this is like the hard part of this homework, but for the drums,
You have to route it.
right? But they used, so for these four, it'll still use these 60 through 72. You just change the program out, but for the drums,
It will be the channel.
but isn't the drums different that you?
Drum is in channel. Whatever program you don't care about program. you have to
Oh,
do it.
channel time touch.
But since not everybody's working on it, right? You're good with Simplify?
I'm gonna work on it later.
Oh, okay, yeah, then.
Alright, so that didn't work. Use commas.
Or we could just work on Simplify.
Yeah, you have to use commas. So then
Would be
it's
it.
locked. It should
Yeah,
be the
exactly.
guitar. Like, you that is not a guitar though.
The output is a number.
Output's up, oh. So, I have to change the message. Yeah. There's the route to four messages.
Oh, those are. The these are
There's gotta be a better way than doing
The
message.
numbers were probably like the program number.
Yeah.
Yeah.
So it's like, no, whatever the hell. it's-
No,
Yeah.
the bass,
Okay.
what do you want to show here, the bass.
So
Right.
it's
But
one for
like the-
piano, it's
Program number.
Program number is
25 for the
So now
guitar.
you just set up the messages.
what?
So what would you be?
Wait,
like,
I'm sorry.
guitar,
Oh, yeah, you can use a
bass,
you have to use a
string,
select,
drum.
right? You're like an expert. One, then it's 25, then it's 33, and then it's 49.
1, 2, 3. Oh, okay, so it's just 0 to 4 in order.
Yeah. I'm pretty sure, and then you could just hold this.
Yeah.
I think it's
Now it'd be,
the other way around, so it's 0, 0, 1, 2, 3, 4, and select. Because it's taking the select. is
Oh,
taking
right, the number that comes out, and then I have to put the messages.
Yeah.
The messages are the.
And you can know it.
So 1,
I'm good.
Yeah.
this is so,
No.
touch design is way better.
Yeah, no, it's a zero.
You're actually trying to
So
do
now
like
just click on the
audio, visual story, that way you're just all interested.
Another question would be how do you use this like to route it to different instrument? Yeah, so this is an X. Yeah, a lot of things just.
No, it's just 0, 1,
Limit
2,
should
3,
be-
right? Did you put the drums in? Drums are in a channel, not program. So you,
Oh, okay.
yeah, so it's just 0, 1, 2.
Yeah, one thing I didn't talk about for that, maybe I miss it, is the drop-down menu thing. Oops. Yeah, so this U menu, once you click it in the unlock mode, you can click this I things at the right, the inspector. So if you want to change whatever it's the menu items, you add it here. And I just found out that it should be comma. rather than that. So bass, guitar, drums, whatever. And then click OK. Then now it will show up those drop-down menus. And so once you see that, now you can see what's going on. These things will basically show which, the order, the key of which one you are grasping. So now, in homework 5, we'll just basically use more select to turn it into setting up the program. Cool. I guess we should work on this first, then the homework. We could think about the homework later. So the ADSR things, let's just do it together, I guess. So we can actually have a new M2F. This will be turning into, MIDI into frequency. So you can now have this key slider, and let's see whether it can actually generate something. So the output, it could be message or number. It's kind of up to you. Message is a little bit trickier to set up. Let's do frequency. So now when I click anything, you can see that it actually turned it into the no number. So 220, 440 in this case. So now you can actually just turn it into a cycle tilde so that you can synthesize the sound. So forget about all these. But anyway, let's just connect it and pull it down. And once you click something, we should be able. And it will stay there forever because now we don't have any modulation. So let me turn it off. So now what we want to do is, well, let me get rid of these. Now what we want to do is with this function output. So this is the function output. We will have set it to, the width to 1,000. Oh, there's this I things. Yeah. So now we will have the line tilde thing. So once again, this line tilde things will take message from the second one, where the second one, we need a bang to trigger this. So now if we click the bang, it will see this is the output. So the output is basically the numbers that we are seeing here, not here. Used to be here. So these numbers just basically describe this ADSR curve, basically. It's the same thing. So now you want to send this to the line function. And the idea is that now this line function will be used as the magnitude to modulate this cycle, this sinusoid function that you have. So what you want to do is just to time them together. So you want to time, multiply function, but now you want to tilde because these are both signals. So that's it. Now you just grab them together and send it to the output. Hopefully it works. So now, well, now the tricky part is that the spam message will set the line, but it won't trigger the MTF. So now you can actually move it here. So now when you click a button, it will trigger both the left part and the right part. So it will trigger, set that MIDI number, turn it into frequency, get the cycle, get the sinusoid. And at the right-hand side, it will have a band message just to trigger the line so that you get the ADSR. So, this will be sort of like doing note on note off for you automatically. And, this is sort of like what we can do with the MIDI keyboard. So think about homework 5. Now you can actually just turn it into this if you want to challenge yourself. But this is sort of like the way to think about it. ADSR is just turning the idea of MIDI note controlling into the specific sound modulating. Cool. We can actually see more here. You can see how the frequency just go up. Kind of boring. Yeah, so this is essentially what I talk about. So you can actually just turn homework 1 into a MIDI keyboard. And you can change the, the attack. Oh, so this thing is a little bit tricky to work with. If you want to get rid of a dot, you press Shift and then you click it and it will be gone. Otherwise, you grab stuff, then you draw. So in this case, now this one need to have an eye here. There's a bug. That's why it's previously not working. Okay. Cool. So now you can hear that delay in the attack. So now the attack, when the attack is very strong, heard that it just immediately go to the very top. Now, if you have a delay of like 400 milliseconds, then you will have that rising amplitude. Anyway, we could also use the keyboard to do it. Let's see. Why it is not working? Let me see. Oh, I'm not connected to the MIDI likely. Okay, forget about it. You can also connect to MIDI node in basically. Cool. So the next thing we will talk about would be the AM synth. Oh, not AM synth, it's additive synth. So the idea of adding, the timbre consists of multiple, as we see in like FFT when we talk about it, like also previously in processing, timbre is determined by the ratios between different harmonics. So you will have like F0 and 2F0, 3F0, and their ratio will basically determine the timbre. So we can use this understanding to actually create the first synthesizer that actually sound better than just single sinusoid function. So this is one of the examples where we will have just like one 440 sound, but now you can actually add the second double the frequency. Now you can actually change the timbre of that sort of. It becomes brighter and brighter when you increase that, to F0. So this will be 1F0, 2F0, and you just add more of that. So the idea here is that, well, it's still the same. 440, you have a 440 sine wave times 1. And then you have like AAT sine wave times 0.2. So this will be, a larger, a stronger 440 frequency thing. But at the same time, you will have AAT that's much faster, like double the frequency. So this will be AAT hertz. This will be 440 hertz. But this will be, 1. This will be only 0.2. So, by just combining different ratios between these things, you can basically just create something. That's the fundamental of additive. So you will have 1, say 0.3. It's always very tricky. And it doesn't sound good most of the time. But you can see how how these numbers just basically change the tone of that. It becomes darker when you don't have those, high frequency component, and it becomes brighter when you have those high frequency components. So basically, all the timbre that you hear, like my voice, I don't know, violin, piano, why are that some of those are brighter, some of those are darker, is basically because, how their, harmonics are composed. But of course, real life frequency is much trickier. It's not always that pure. It's usually, fluctuating between different frequency rather than staying on a specific frequency all the time. But anyway, you can do it this way. Now, basically, this is like only 440. It's kind of boring. What if we can just turn it into, like a frequency based on your inputs? So you have like a keyboard. Now you can turn it into, this is the frequency 264.6 that was sent to the first cycle things. So this will be the first F0 and you times 2. So now you get 522. Then you have the cycle, the second one, the third one, the fourth one. So now this is like F0, 2F0, 3F0, and 4F0. So, you can create all sort of stuff based on this. So 1, let's do 0.2, 0.1, 0.05. Whoops. And so, this is sort of like the basics of additive sense. So not too tricky, basically, just doing that. And, these numbers are not so straightforward. So typically, if you want to do it in a more intuitive way, is that you should turn it into a slider. So think about this way. This should be much better. This will be your cool. So that's the most basic format of what a synth could be. And, on Wednesday, we will talk about FM synths. Then you will realize this is, just a start. Cool. Any question on this? Likely not too tricky. Just add in different sinusoid. So think about it the opposite way of FFT. FFT is trying to, well, you have a waveform, decompose it into multiple sinusoid function. And at the early stage of computer music, it's like, well, now we have this sinusoid function. We have that sinusoid function. If they have specific value, if we add them up, can we tune the timbre? And you can see here that, well, you can change the timbres, and it does make some sense. But at the same time, it's like, well, we're so far away from anything that's, sort of like modeling real life sounds, because real life sound is much more complex. But in this case, this sort of could remind you of some of the early, computer music sounds, that some of the synthesizer sounds. Cool. That's additive. I think we could go over AM synths, and we can spend some time on looking into some of the homework 5 stuff and see if I miss anything. Cool. So AM is, you likely know about it from the radio, even though I mean, unless on car, there's rarely people listen to AM. But AM is basically using the amplitude as the modulator. So you are modulating the amplitude. And so there are some technical terms. So usually we call the base frequency, the sinusoid function, we call it carrier. And we will have a modulator on top of that to modulate that carrier frequency. So in this case, the carrier will be 440. So the 440 sinusoid, let's just keep it there. Now you will have a modulator that changes that magnitude dynamically. So in this case, you are changing that magnitude as a sine wave. So that's why you see that it just go up and down. So pretty straightforward. But at the same time, you could also do other things like this. Let's see. There's nothing here. So this is like basically just showing that why AM becomes interesting. So if you like have a 440 frequency, 440 hertz stuff, and then you use frequency 1 hertz things to modulate it, it's like this like weird effect. But as you increase that things, it actually will, if you look at the peak, it will actually split it into two things. So that's because, when you are modulating the original frequency, you are actually also creating another frequency. So that's the interesting part of AM is that, when you have a very high frequency as your modulator, you are essentially creating new modes of that. So you are essentially creating F0 plus that frequency and minus that frequency. So, that sort of will bring us next to the frequency modulation, where now we are modulating the frequency. Cool. I guess we will look into FN synths on Wednesday. We could reserve some time for homework 5 debugging. Any question on that? Have you started? Kind of. Yeah. Okay. Yeah. You get the ADSR done? That's good. I think so. Yeah. Okay. Cool. Yeah.
Right, or bring that in the homework, but I cannot get the key off. I've been trying to connect various different things.
So basically, you still need to know this likely involved in So yeah, you set so media is like you turn that node down, telling a specific pitch. But key up, then you will send a node up to turn that pitch specific. So you also need to know when you are up.
Oh, well, you just send a node out with zero velocity. Yeah. So then it will be
Cool.
There's so then I think you just do
Zoom folks, do you have any questions on homework 5?
I have a question about the whole drum thing. That's
Mhm.
way to do it. To pitch it down, like, are we supposed to use the long message thing? Like this stuff? Because we need all of these numbers to be 25 less when we do drum. So can we use like a if statement and then do a subtract? Or are we supposed to just copy the whole thing and subtract all the numbers?
You should do it that way. I mean, just minus 25. So to do it, you can actually use the minus thing. So you
I
can,
don't think we went over like the if condition.
you don't really need the if condition. That's different in Emacs, is that you will have this minus thing
Yeah.
and it would default to 0. And then when you have drum,
The message is triggered.
you trigger it to set it to 25. So now you have drum.
It's not triggered the operator.
Or it should always go through it, it'll just change it to 0. Okay.
And so when you don't have drums, then you will have a 0. And I mean, these things doesn't have to be triggered. So when you select drums, you set this become minus 25. When you don't have drums, you set it to 0. But the node is triggered by something else. So this is code, this is hard, right? So you don't necessarily need to write an if else. It's just totally different mindset, yeah. So the idea would be you will have a minus thing, which differ to 0. And when you have drums, you turn it in the other way. But you could also just do it another way that, well, your drums just support that 3 notes. It's fine.
I'm so confused on like node on, node off. How would you create a node that lasts indefinitely? So like
Node out will last indefinitely.
node out,
Node on, it will prove.
node on.
Yeah, if you just send a node on, it will just keep it. So if you're using piano will decay anyway. But if you're using an organ sound, then now you send a node on, it will be there forever. There's no way you can close it.
Oh, so if you set it to
Organ like 9 or 10, you will see it. You click no on,
It'll-
won't stop.
oh, the decay isn't isn't the.
It's just like a looping sound.
No, that's essentially what we talk about in ADSR. So the thing. So basically, you know, piano has its sustain very low. So whenever you click it, it would just you couldn't hear the sound anymore. It would decay, sort of. But if like organ, if you just have a note down, it would just stay there. So that's the default behavior on your MIDI synth. And
Oh.
usually most of the sounds will get out, but it won't close it. I mean, it's still there. Just that your synthesizer is like too low on that particular
Oh, so
more
you think
percussive.
that's, like, the reason why you don't hear it on like the piano setup is because the sustain is too low?
Yeah.
Okay.
Or, you know, there's something going on with that MIDI synth, but usually other than organ or lead, like all the synthesizer things, usually they will just fade out. That's the default behavior of MIDI keyboard. MIDI synths. Yeah.
So I think then the easiest way to test whether or not key up is working is to use an organ or something.
Yeah, exactly.
Okay.
So otherwise it's a little bit tricky. Yeah.
The strings too.
Yeah, the strings, yeah, exactly. Yeah.
It's staying.
So, you know, especially like drums, there's no way you can see how key up affect.
So
Yeah.
when you want us to use key up, in that sense, you want it, because the piano sound itself is a one shot.
Mhm.
So when I hold for the string, well, you can't hear it, it's in my headphones, but like,
Yeah, I mean, piano won't change.
piano won't change, right? So that's there.
Yeah.
So why do I need key up? It works.
That's because you have the note in.
Oh, sorry. Oh, so you want the key up.
Yeah, it's for your keyboard.
Got
Your,
you.
yeah.
And can I reuse my select? Can I put the key up in here and then have,
it will be kind of tricky.
it won't work, right? So I have to copy the whole thing for key up and then change this to be a make note with 0 velocity?
Not make note. Make note will do a pair of note on and note off. So now you don't want make note.
So you just make a note off.
So
You just make a note on with 0 velocity.
yes, so note on for key, note off for key up, and make note will just gone.
Oh,
Because
no
you-
make note.
Yeah, because make note will always give you a pair, and you don't know what the duration is.
Oh my goodness, the wiring looks.
Okay, how do I, okay, so this should all just be note on.
Yeah, you can just click it and become note on.
Oh, I can just go. Can I just go no?
It shouldn't be, no, it's not note on. You have to sort of like compose it. So we have it in one of the homework, one of the thing. I mean, the easiest way is not by composing it to the note in. You know, when you have the note out thing, right? The note out thing, and there's basically 3 outlets. So now you can connect the pitch to that. And the velocity will be something preset 100, and channel will be
out.
0 or 110. So this will be node on event. Now for node off event, then you will have the same pitch. You also detect it somewhere, but now you will have 0 as a message.